Let's solve the following problem, which asks us to prove directly from the definition that the limit of the square root of n as n tends to infinity is infinity. Well, what does this mean is, that this sequence that consists of the square roots of the natural numbers diverges to plus infinity. And which definition is this problem referring to is the definition of divergence to plus infinity. So all we need to do is to recall the definition for a sequence to be diverging to plus infinity and show that it is true for that statement. For this sequence, it applies. So we need for all, so remember the definition, for all we need the following. We need to show the following. For all capital K greater than 0, there is an index capital N, a natural number, an index, such that a little n, the nth term in the sequence, will be greater than capital K for all indices that come after capital N. Okay, so let's plug in for an the square root of n. So what we need is that for all capital K, we need to find capital N such that this inequality is satisfied. Okay, so we fix K to be some positive number, and now our task is to find capital N. Okay, once K is fixed, just think of a positive number. Fix it to be 10 or 100 if you want, but the point is that it could be any positive number. Once K is fixed, what we need to do is to find capital N that this inequality holds for all little n that is greater for capital N. Well, the square root of little n should be greater than the square root of capital N if this inequality is true. So if we are looking for capital N and we want to have this inequality for all little n that are greater than capital N, well, if little n is greater than capital N, then their square roots will also have the same relation. So the root little n is greater than root capital N, which if we set it to be greater than, so this is what we are using, that this sequence is increasing as little n increases. If we take, and let me write this separately, if n is chosen for 2, so it satisfies the following inequality: the square root of capital N is greater than capital K, that fixed positive integer, then we are done. This capital N will suffice, will be good for our purposes. So how do we choose capital N? Well, let's just square this inequality. And if we square it, we get that capital N should be greater than capital K squared. So K is just some fixed positive number, we square it, and we look for the next integer, the next positive integer that is greater than capital K squared. So any capital N such that this is satisfied, any N with this being satisfied will be a good choice. Okay, since if we have this inequality, then we have this inequality, and then we have that inequality, showing by definition that our sequence of square roots of natural numbers will tend to converge to, that is, diverge to plus infinity as n tends to infinity.